Hi folks, we're going to take a look at number 21 on page 377. So they give us two pieces of information here. They tell us that 2 to the a equals 5 and 2 to the b equals 3, and then they want us to use this information to find an expression for log base 3 of 10. Okay, this is actually a multiple choice question, so we should be getting one of the answers provided in the multiple choices. Okay, so let's see. The first thing I notice here is that the information that's given to me are these exponential equations using base 2 for the exponential expression. Yet the thing I'm looking for is a logarithm of base 3. Okay, so that tells me that there's probably going to be some sort of change of base that I should be using to solve this problem. And in fact, I think that's the first thing I'm going to do is I'm going to start with that expression they're asking me to determine. Okay, log base 3 of 10, and I'm going to change that into logarithm of base 2. So how do we do that? So we take our new base, and first we take the logarithm of the original input, so log base 2 of 10, divided by the logarithm of the original base, so log base 2 of 3. Okay, so just to repeat how this works, with our new logarithm base, we take the logarithm of the initial input divided by the logarithm of the initial base. Okay, so now I'm working with two logarithmic expressions that have base 2, so hopefully I can find a connection between these two expressions. So I'll label this one number 1, I'll label this one number 2, and actually the one that seems most promising right off the bat is number 2. Okay, because if I take 2 to the b equals 3, and I take log base 2 of both sides, okay, useful because on the left hand side I'll just get rid of that base 2, and then if I take log base 2 of the right hand side, I'm going to get exactly that denominator. Okay, normally I wouldn't show this step, but let me just be really clear as to what I'm doing. I'm taking log base 2 of both sides. Okay, and here remember that 2 to the x and log base 2 of x, these are two inverse functions, so if I apply them one after the other, I just get my original input back. So this is just equal to b, and that's equal to log base 2 of 3, which is exactly the denominator that I'm working with. Okay, so there we go. We just figured out that this denominator has to be equal to b. So now let's see what we can do with the first piece of information that was given. So I was given 2 to the a equals 5, but I'm not going to do the same thing right away, because I don't have log base 2 of 5 here, I have log base 2 of 10. So I think I need to change this equality a little bit. So how can I do that? Well, how do I get to 10? I just multiply this by 2. Now, if I multiply that by 2, of course I have to do the same thing to the other side. And that actually works out quite nicely because it's the same base as my power. So I can now use my first exponent law to write this as 2 to the a plus 1, which is what I want, a single exponential expression equal to the number that I want, which is 10. So now I'm going to take log base 2 of both sides. Okay, and I have something that's going to be very helpful. So again, inverses of each other, so I'm just left with a plus 1, and that's equal to log base 2 of 10, which is exactly the numerator that I need to rewrite. So now we can find our expression for log base 3 of 10, numerator a plus 1, and denominator log base 2 of 3, which we found was equal to b. And there we have it. We have our final answer. So if we look at the multiple choices here, I see that that is C. Okay, so number 21 answer should be C, which is a plus 1 over b. So just to do a recap, because this is a good example of a thinking question, so you might not get something that's exactly the same, but you might be using similar ideas. So first of all was to notice that the information that was given was all in terms of a base of 2, whereas what we were looking for had a different base in the logarithm. So this idea of doing a change of base to start, and then once we did the change of base and we had logarithms of base 2, we were able to find patterns to fit the information that was actually given. Okay, that's it for this one.